If I'm thinking about the next evolution of the data ecosystem, of data infra, where do you see us heading?
It's an inflection point, right? The big elephant in the room, as we alluded, is AI, and especially agentic AI. We are barely hitting like cloud architecture readiness. Forget about AI readiness.
What actually unlocks these AI agents to be able to build and maintain and fix and optimize pipelines at scale?
You have to have the metadata about your system very easily accessible. I think with agents, you need everything to be the source of truth.
How do you manage platform at those different scales? What's really different in terms of the underlying infra, and how do you serve users or customers of the platform at that scale?
Failure is a constant. It's going to happen every day. There's going to be machines going down. We've seen so many problems on this behaving strangely, and then suddenly your performance profile goes haywire. Observability becomes key, just kind of knowing what's going on in such a large system and then reacting on that, right? What should you do?
Hey everyone, thanks for listening to another episode of Data Innovators. Today I'm speaking with Renu Tewari, former Senior Director of Data Platform at LinkedIn and an entrepreneur in residence at Bain Capital today, ideating some new ideas in the data ecosystem. Renu, thanks so much for chatting with us today.
Hello, Roy. Thanks for inviting me here. It's really happy to be here.
Maybe let's start at the beginning. Tell us a little bit more about your journey from a file system engineer at IBM all the way to leading data platform at LinkedIn.
Yeah, it's been a long journey. I think I call myself a plumber, right? We kind of live in the basement of building the foundations. So I started like from the ground up, like operating systems, file systems, working inside the kernel, good old days with the Solaris kernel, and then, migrated to Linux and, thinking about like distributed systems from day one. And I think slowly growing up the stack, right? So from the ground up into like data, we started at, building a file system. This is like the pre-big data and Hadoop era, right? Trying to build parallel file systems. In those days, it was, for multimedia, it was, the idea was that you could have streaming video. And that was like, mind boggling at that time. And then, Netflix came about and then changed the story. And so this was like a file system for, it was called GPFS for multimedia. And then it grew into like a parallel file system and then became like the bedrock for like even internally for big data and running analytics on it. And then, I grew with that into like PubSub, into analytics, into like data lake houses and, all the new architectures that we have today. But still a plumber at heart. So I still like to sit in the basement. This is not sexy stuff, but this is what things are built on. Right?
Absolutely. Some people might, think differently about how sexy it is or not, but including us, I think both of us. Tell us a little bit more about your kind of last year or two at LinkedIn. What did your team focused on, build, who used it? Tell us a bit more about that.
Yeah, so I think my journey at LinkedIn, I think we were talking about like I started with PubSub and Kafka teams, and we hit like scale limits. So we started with like 1 trillion messages a day, and we thought that we could scale up to 10 trillion. And the last check, we were at like 35 trillion messages a day. And so we hit those scale limits in Kafka, and then we rolled out a new PubSub system called Northgard, which was internal. I think recently LinkedIn publicly announced it while things have been migrating into that. And one of the reasons was like the scale challenges, right? Things that you build initially, you always plan like 10x, 100x, but you don't think of like 1000x difference. And then you have to go back to the drawing board on everything you thought was not a bottleneck becomes a bottleneck, right? So, and then my team was also looking at all the data pipelines, the lakehouse, and we had a traditional lakehouse built out of HDFS in our own data centers, and it was using Hive Metastore a lot on Spark, and then we used Trino for interactive queries, and we kind of hit. I think everybody in the industry did having issues with Hive Metastore, and then we just started our migrations into like Iceberg, and we built this thing called Open House, which was to build this kind of managed Lakehouse experience in terms of governance and security and doing like housekeeping tasks and optimizing the Lakehouse for the type of queries we had. Right, so that was a big focus on self-serve as well as a well-run, well-governed lakehouse. And that was kind of the direction that we were going. And one of the very interesting projects we started was convergence, where we are looking at like, the traditional Lambda architecture where we have real-time data, and then you have your hourly and daily and monthly data that you are collecting for a lot of insights and trend detection. And then you're doing these backfills between these two systems. Systems were very siloed, and that made like the life of the data engineer much harder. It made the life of the analyst much harder because getting data, getting fresh data, getting real things was always slow, right? It was gated by these pipelines. And we're trying to do convergence. We're trying to look at, can I have the same stack for both real time and batch analytics? We started exploring with something we built internally, trying to see if, I could move like, we talk about time travel inside lake houses, but this was time travel between a lake house and your operational side, which was traditionally sitting inside Kafka, right? So can I time travel right up to the minute that is available on the operational side, right? And trying to bring the operational part of the world as well as the analytics side of the world together. That was a challenge. I think it still remains a challenge. It seems to not have moved as far as I thought it would move, right? So we had like Flink having Flink batch and Spark having Spark streaming, but we never got that uh, best of everything in one solution. So that was something we were still actively working on when I moved to trying to explore something new.
Yeah. So, you touched on an interesting point that I'd love to kind of double click on. You mentioned starting in the Hadoop HDFS era or ecosystem, and then evolving much more into a lakehouse ecosystem. We had benefits of both Spark, batch analytics, Kafka streaming, Trino. As you see the ecosystem continues to evolve today, and Lakehouse becoming such a big element or component of the data platforms that especially high scale teams build today. Where do you see are the biggest strengths for the Lakehouse ecosystem, and kind of where do you see that kind of going forward as the ecosystem continue to evolve?
Yeah, it's a great question, right? I think we are at the threshold of a lot of change, right? We started off with traditional warehouses, and then we went to like cloud warehouses, which was more about scale and the separation of compute and storage, right? And so that you could scale independently, right? The compute layer and the storage layer is not tied 1:1, and that brought about like enormous flexibility. And now when you look at all these, data becomes a hostage of the format and then of the engine, and you want to free your data, right? And I think the open formats, whether it's Iceberg or Hoodie or even Delta, it brought that thing that your data is now free. And what that means is that you are not tied to a particular engine. You can use a different engine with the same data format, and you can use the best engine for the job, right? So we had Spark, Trino, and Flink in our ecosystem, and they were all optimized for different tasks, right? It wasn't that one engine could kind of rule it all. I always say, right, if you build something that, is one size fits all, then it fits no one, right? So that's kind of enabled now with these kind of new lakehouse architecture.
You also mentioned building, starting to build for thousands or even millions of events, and then ending up having an infrastructure that supports trillions of events. You talked about the 1000x scale up. How do you manage platform at those different scales? What's really different in terms of the underlying infra, and how do you serve users or customers of the platform at that scale?
That's a great question, right? Every time like your order of magnitude changes, the solution changes, right? So you think that, if you can handle 10 million, what will come and bite you are the bottlenecks, right? So if when we started originally in the pub sub stack, right? You simplify that, hey, metadata, let's just put it in Zookeeper, right? And you think about scaling your data, and so you shard it, right? And so now you've partitioned everything. But what's the simplest way to partition? You just hash on some key. Right? And then now you're going to start seeing problems of hotspots. And so what do you do with hotspot? You start moving data around because you want to mitigate the hotspot. You try to do repartitioning. When you do repartitioning, you're going to lose affinity. And soon you'll see that all those design assumptions you made at some scale level, they're going to start failing, right? Because now you're going to have so much of housekeeping in managing, load and managing how you're partitioning. How do I maintain affinity? Your metadata is going to come and bite you. So understanding those bottlenecks and designing for those bottlenecks becomes really important, right? Is your NIC overloading? Is your IO actually saturated? Or is it, your sharding is not going to actually scale with different use cases, and you're not going to be able to predict traffic patterns that early in the life cycle, right? Infrastructure stays around for at least a decade, right? You don't really rechange things. You upgrade and you migrate, but you don't fundamentally change your foundation, at least in that cycle of a decade. It's not every year, every 6 months, and that's the mistake you make, right? You think like you can change that fast, but inertia is real. Like Newton's first law is real.
Especially at that scale. So it's like, moving 1 degree of a big carrier. It's like an aircraft carrier. It's like
so you have to really think about like migrating customers. There's a whole ecosystem you will build around that infrastructure. It's really hard to. It's much simpler to build a new thing. It's much harder to migrate everybody from the old to the new, right? And maintain the same semantics. So always have to plan for much more than what you are at today. But when you rethink on the bottlenecks, especially when you're designing for scale, right? Everything you think is not a bottleneck will become a bottleneck at some scale, right?
And I'm curious, you mentioned those bottlenecks and figuring out volumes and how things change and evolve and run times, and all of a sudden performance is degrading. Are those things, again, if you look in retrospect, are those issues or bottlenecks that you found, that you were proactive about and found or thought about beforehand, or were those things that because of the fast scaling, all of a sudden you see yourself or find yourself at 2 a.m. finding that something failed because the bottleneck was reached, and all of a sudden it's a fire drill around, okay, how do we redesign it, or at least have some patch in order for it to work in the short term?
So I think at 2 a.m., you're not going to redesign anything, right? You're going to just bring the system back up, right? So I think everybody will see that whatever you've designed for, you cannot predict the unpredictable, right? So things are going to happen. I think you have to be ready for failure. One thing is like larger scale systems. I think failure is your only companion. It's always there, right? And you have to design for the fact that something is always going to fail all the time, right? It's not like once in a while that you can fail over your workload. It's going to just be your disks are going to fail, your network is going to flip flop, your machines are going to have problems. You might have a whole cluster go down because of a switch issue, or you upgraded something. It's a lot of times what we see is just config problems, right? You roll out something, the config changes, and then the system kind of keels over. So at 2 a.m., I think your plan is mostly about bringing the system back, right? And notifying your customers and your stakeholders. I think the post-mortem happens after this thing is back, right? So, but yes, having that post-mortem is really important for the team culture to have, right? To look through why things went wrong, to understand the root cause. A lot of times when we think this is the root cause, it's not really the root cause, right? So we had this ethos of asking 5 whys, right? So why? So till you get to the root cause. Otherwise, you sometimes say that, oh, this happened because we had this library that was calling this thing, but why were you calling that library? And why was this load X? And then the more you dig into it, that's when you find the real root cause, right? Not the trigger event. So I think we confuse sometimes the trigger that caused the failure from the root cause. And I think that's what the postmortem really helps you identify.
No, that's a great point, right? Because one, if something always fails and you need to prepare for it, it becomes I love the thumbs up. It becomes a question of how quickly can you identify that something fails and how upstream. And secondly, the five whys that you're asking, this is the point where you need to have this full visibility to be able to answer those again quickly enough and in the right context, and of course in a meaningful way. So both the idea that you need to always be monitoring and detecting the bottlenecks and then be able to answer those five whys, I think becomes very important when you scale up, especially when you do that fast. And if you want to move fast and break things, obviously you need to always complement with sound like this becomes a very important element of part of the infrastructure. Is that fair?
Absolutely.
Okay, great. So you mentioned the scaling to 1,000x and building for millions versus trillions of events. Talk to us a little bit about that. What are some of the differences? How do you do that? What is the implication on the infra team when you build, to this scale, growing that fast? Talk to us a little bit about that.
Yeah, one thing you have to realize is when you change your scale 100x, the solution, your architecture is completely different. You cannot, retrofit it. You cannot throw hardware at it. It's not going to fix the problem, right? So one is that realization that if you're going 100x from what you planned and designed for, then you need to redesign, right? And then I think the thing that hits you is the bottlenecks become very clear, right? And the bottlenecks change with these kind of workloads with, sometimes, you have memory bottlenecks, and then you'll see that when you start initially, people actually focus on the data side where they come up with sharding techniques, and they'll say, okay, you use, how do you shard? You have a simple hash function based on key. And then soon you start hitting load imbalances, you see hotspots, and then you'll have to move the data manually to actually load balance, because otherwise you're going to be gated by your poorest performance partition, right? And then the thing that you overlook is the metadata. And most of the time it's like, hey, just throw the metadata into Zookeeper or throw it into some, transactional database, and that will scale and give me the consistency that I need. And that will become your bottleneck because you haven't planned for the number of metadata operations you're going to do. And those become harder to actually fix, right? Because now you want to build a distributed metadata store that can scale, and those things are hard to get right. And you talked about when you build smaller systems, I think you can have an HA solution and then you can just fail over. Whereas when you have these kind of always on super scalable systems, you're going to realize failure is a constant, right? So failure is always there. Failure is something that you're not planning for once in a while. It's going to happen every day, right? Every minute. There's going to be machines going down. There's your NIC that will flip flop. There's going to be disks that will start rebuilding. So we've seen so many problems on disks behaving strangely, and then suddenly your performance profile goes haywire because your timeouts have to change. You think something is dead, it's not dead. And so those kind of things will come up for larger scale. You'll see that if a probability of an event is, something to the -5, but now you multiply it by 1,000,000,000,000, now that thing is going to happen all the time, right? And so those are the things where observability becomes key, just kind of knowing what's going on in such a large system, and then reacting on that, right? What should you do if performance is going to change based on misbehaving hardware? on the change in your traffic patterns because you did not expect this kind of a bursty nature. A lot of times you see diurnal patterns where things are up and down during the day, but then you see these large bursts because somebody started launching some new application or restarting some backfill process, and then you see these big spikes, right? So having the observability to kind of know what's going on in your system becomes like something you need from day one when you have a super scalable system.
Great. If I hear you correctly, it sounds like failure is a constant and always on monitoring is a must, because it sounds like detecting early and quickly is the name of the game. And now that you are understanding the bottleneck in your new scale, I assume there is a big postmortem coming, and how do we redesign it go forward? So share a little bit about the kind of approach to those postmortem, and how do you come with a new design that you need to support?
Great question. So I think postmortems always happen after an incident, right? So you have something, and based on the severity of the incident, at the time of the incident, your focus is to bring your service back on, right? And you inform your customers, you inform stakeholders, and you get back to meeting your SLA. But after every incident, is really important to do a postmortem to really understand the root cause. A lot of times we confuse the trigger for some event happening, you know, to be the root cause, but that's not the root cause, right? The root cause is what the design based on certain assumptions that has failed at that point, rather than, hey, I saw a big load and something failed, and that's not the root cause, right? The root cause is not the load, that was the trigger, right? The design is the root cause where you assume that your metadata could handle X when it's now 100X, right? So things like that. So we had this thing of asking 5 whys, and I think a lot of companies follow that, where you ask your first why as to, why did this happen? Oh, because load changed. Or why did the load change? Because this happened. And why didn't he support that? And you kind of dig into that chain of whys till you hit the root cause. And it's important during your postmortem to really identify what the root cause was, rather than, and that sometimes triggers you to redesign things. To improve your observability, because sometimes you don't know that chain of events because you don't have the metrics to track it, or you don't have the ability to trace it. And a lot of times logs get recycled after 7 days, and a lot of times you just abandon that root cause because you don't know how to get to it, right? So having that instrumentation in place is also important for you to get to the root cause. And then when you realize that, hey, maybe it's the design that is just not suitable for the scale, you got to redesign it then.
Yeah, and I assume frustrating when there is a failure, you detected it, now you're trying to understand the why, and all of a sudden you get, you're hit by a wall because there are no more logs, there are no more visibility.
Exactly.
You can't go to the next step, and now it's like pulling teeth in or hairs in terms of how do we get there to the answer of what actually happened, and obviously you don't want to recreate
and there'll
the
be,
situation.
you will see like the number of tickets that just get closed because you didn't have the logs, right? Or you didn't have a sufficient information, or you would have the on-call engineer saying, well, we tried it again and nothing happened, right?
Yeah, you
So
can reproduce, and now
you
you're just
can't
doomed for it to happen
reproduce.
again next time at 2 a.m. when you're least
Exactly.
expecting. Yeah. Great. Yeah. Always fun to be the on-call engineer that gets the call.
Yeah.
So, we talked a little bit about kind of the journey and the evolution from the HDFS and Hive Metastore to the modern kind of Lakehouse ecosystem. If I'm thinking about the next evolution of the data ecosystem, of data infra, not to mention the AI in the room.
Yes, that's
where
the
do you see us?
elephant.
Yeah, where do you see us heading?
It's an inflection point, right? So if you look at the lake house, right, we've come to now this open lake house where we are not, data is free. It's not held hostage to a particular engine. You should be able to use any engine of choice. And so, great question on where are we going, right? And the big elephant in the room, as we alluded, is AI, and especially agentic AI, right? So where people are talking about AI agents, which are, you assume an agent for a particular task, uh, and there's a talk about like just as we had the microservices architecture, now there's like an agentic hierarchy and agentic workflows. And if you look at the infrastructure today, right, we are barely hitting like cloud architecture readiness, right? Forget about AI readiness, right? Nobody is even prepared for what could happen if you have a lot of AI agents. The kind of load, the kind of variety of queries that they could run. I always say that human stupidity is bounded, but agentic stupidity could be like limitless, right? So to your point, right, getting back into like knowing what's going on would be even more, it's going to be 100x, 1000x more complex, both in scale and the variety and the type of queries, because a lot of agentic workflows will be iterative. If you have an agent trying to build a pipeline, if you have an agent trying to query your data lake, it's going to be iterative because it's not going to get it right. You have to have like the ability to handle that load, the ability to handle strange SQL queries. Governance becomes important. Performance, right? It's not just about the performance of the query of the agent, but about all the other queries that you're running, right? You could have like noisy neighbor problems, you could have overload, and you could have like performance that, a lot of AI is not even deterministic. So you don't even know what it does in the next loop. And observability and knowing what your baseline is, where your anomalies are, being like real time about that becomes really important because as we talked about, right, logs are going to disappear. Think about how many logs agents are going to generate. It's going to overflow your infrastructure to the point where you're not going to be able to have any visibility on what's going on, right? Uh, so I think this is an inflection point for us to go back and think, as we talked about, right? When scale changes 100x, a lot of things have to be redesigned. And I think with AI and agentic AI that's going to hit data infrastructure, especially, we'll have to look at how are you going to redesign it.
Yeah, and agentic data engineering is the key, maybe one of the biggest value unlocks in data engineering in general, both from productivity, velocity, ability to support new use cases, new business use cases. You talked a lot about the guardrails that we need to have around it, um, both in terms in depth and performance and real timeness of it. At the core of the agentic value, what needs to be there in terms of the foundation? What actually unlocks this AI agent to be able to build and maintain and fix and optimize pipelines at scale that potentially is missing today, or the teams need to have in place in order to make it a reality?
I mean, a lot of it would be like you have to have the metadata about your systems very easily accessible. So people are already talking about semantic catalogs, the ability to build like vector searches on these semantic catalogs so that you can talk English. Like there's this thing about English being the new SQL. And, I've seen this so many times. Like SQL has been there for 60 years. I don't know how many years. It's longer than I've been on this earth, I think. Right. So, when during the big data revolution, we thought we don't need SQL, and now we've come back to it. Now there's a whole revolution around like having English. And more than English, I feel like the ability to reason, right? The ability to get feedback and to improve. I think that's the value that AI agents bring, right? They're not static. They are not tied to like, hey, this is the query and that's what it stays, right? They are always improving, right? And they're iterating and having infrastructure, the right metadata, the there was a push about going more like shift left where you want to do your analytics closer to where data happened because it's more reactive as well as it's cheaper because you don't have to now have these pipelines. And then there's also a push with agentic to be more consumer driven, right? So the data pipelines have to be driven from the consumer of the data, which is your agent, rather than the producer of the data, which is what the traditional thing is, where the data engineers who are producing the data will set the pipeline on where should it be ETL'd into and what's your ingestion story and what is your medallion architecture story, and all those design patterns will change a lot more.
And you touched on the metadata and potentially semantic layers or catalogs. There's an interesting discussion right now around active versus maybe a little more static or inventory type of metadata. Um, in the world of AI agents, again, building and fixing and optimizing pipelines, how do you see active or dynamic metadata plays into that, and what type of metadata do they actually need to have in order to unlock this value?
Yeah, so everything has to be dynamic and source of truth, right? So a lot of, our data catalogs used to be what is a reflection of truth, right? They are, post facto, you have mined what is the type of tables, what is the schema, what is, who is writing who, what is the lineage of the data. Those things were kind of after the fact, right? I think
Preset,
with
yeah.
agents, you need everything to be the source of truth. That is the ground reality, because the agent's going to actually assume that is the ground reality, and it's going to make decisions for you on that, right? So the current, it's not just about the data currency of that metadata, it's also like it is fact, right? Because that's what the engine is seeing, that's what everything is seeing, right? It's not a reflection of truth. And so the catalogs have to kind of reflect that and have the ability to then answer queries that are more semantic, right? Because if I'm looking for weather and I need to understand that that maps to the temperature column, that is not something SQL can do, right? So that has to be done at your semantic layer, whether you're doing vector search and similarity search, that will bring you to that mapping, right? And that's where agents will become more powerful, because now they can understand that mapping and really unlock the power of the data that you have.
And if I tie it back to what we just talked about 10 minutes ago around bottlenecks and performance, it sounds like it all needs to be tied together.
Exactly.
How the data layer, pipeline layer, context layer, infrastructure layer all tie dynamically. What actually happens, what you call that, what is a fact, what is real versus preset or predefined by some user in some design document maybe 2 years ago, and since then, who knows what changed. So like this is key, especially as you want agents to really look at the full realm of possibilities around pipeline maintenance, and not just in building, of course, and not just specific narrow areas or use cases.
Exactly. Because now think about it, right? Now your agents are like, they're never going to sleep. They're going to run 100x than what your human users would be. And so the bottlenecks that you have in this whole infrastructure pipelines, they're going to be very real, right? So you can do only as, so people talk about, everything bigger, faster, cheaper, right? But you're going to be gated by that bottlenecks that you have, right? So you cannot get to that bigger, faster, cheaper. You cannot really get that value from your agents if your infrastructure cannot handle that scale, right? Or you don't even know what's happening, right? And thinking about, I keep bringing back to observability, because if you don't know what happened, right? If you don't know your baseline, if you don't know the anomaly, you won't be able to fix the problem, right? You won't know what the bottleneck is if you haven't measured it, right? Everything in data, if you don't measure, it doesn't exist. That's the way it goes, right?
So if you had to have one advice or give one advice to teams that are starting or in the process of scaling their infrastructure, redesigning their infrastructure today, very broad, what would your one advice to them?
So infrastructure is like your foundation, right? It's like the engine of your car, right? So I feel like don't make a rush to selection, right? Like, based on your current needs, and you just go with, hey, what's the simplest thing that I can do to get it up? I think you need to really plan for, hey, what is the future? And think about, like, for 10 years, you're going to be using that same infrastructure. So the choice you make today is going to impact your ability to grow, to build, to compete, right? And to manage for the next decade, right? So you got to really do that perspective plan. Don't really jump into, like, this is the flavor of the day. This is the, everybody goes on, this is, let's go with Snowflake or Databricks, or just go with XYZ, right? You have to really think about, how do you think things are going to grow? What would it be? How does it add value to your customers? Understand that use case first before making that decision, because that decision is going to stick with you for infrastructure is like getting married, right? So you got to stick for at least 10 years together.
All right, so plan for the next decade. That's a
Exactly.
good advice. So Renu, thanks again for joining us today. Before we wrap, if people want to follow you and the work that you're doing, what's the best place for them to go?
Well, I will always say LinkedIn. So just follow me on LinkedIn. I think, I track that. The most social media that I am on is LinkedIn.
Fantastic. So we'll make sure that we'll have a link in the episode description. Again, great conversation. Always appreciate the insights. Thanks for joining us.
Thank you, Roy. My pleasure being here.
Amazing. Bye-bye.